Do you want to convert your words into numbers? But why would you do that? Have you ever wondered how machine learning and deep learning algorithms like recurrent neural networks, artificial neural networks, understand these text data and extract important features from it? So these are the questions we are coming when solving NLP problems. So we know that these algorithms only take arrays of numbers as input. So, like deep learning, if we talk about deep learning algorithms like ANN, RNN, and CNN, so these take an array of numbers as input and make calculations and predict the output. So how do we convert these text data into numbers while preserving the semantic and syntactic relationships between words? So we have a word, like we have a sentence, and we want to convert this sentence into numbers without losing the semantic and syntactic relationships between the words. So we shall discuss about what is the syntactic and semantic relationship. So and this is all done with the help of technique called word embeddings. So we have a technique called word embeddings. With the help of this we can convert text data to numerical inputs. So today in this video we will discuss what word embeddings are, why we use them, and the various techniques to create word embeddings. So let's start the video. So word embedding. So we have word embedding. So let's say we have a sentence like this is a boy. This is a boy. So this is a sentence we have, and we want to convert this into word embedding. So basically, word embedding is like the numerical representation of this. So I can give the number as 1, 2, 3, 4. So this can be the way we can convert. We can give the number as like this. And suppose we have another word. He is a boy. He is a boy. So basically, this sentence was not correct. So he is a boy. So we have seen that is represented by 2. So is represented by 2, and A is represented by 3, and boy is represented by 4. And he is not represented by anything. So he for the word he, we can give a number of like 5, because we have already words have 1, 2, 3, and 4. So we can give he as a word 5. So number 5. So number 5. So this is the array. So we have a array and we have a neural network like this, and we give the input into the neural network and further processing the neural network like this. So we have a hidden layer, and this is the process. So in the input layer, we are giving the input as this. This is the array. So these are the word embeddings. So here is the word embeddings. So here you can see in the pictures like this. So it is a dimension. So here you can see 3 dimension like x, y, and z. So in the x, you can see that king is related to queen. Like king is a raja and queen is rani. ठीक है? So ये क्या है? King and queen is related to each other, and man and woman related to each other. So these are the these are represented with the help of vectors. So in the like in numbers, this cannot be represented like man and woman through the space. So we have converted like this into the numbers. So we will discuss about how these converted to numbers. So another example is walking, walked. So walking is a walked, similar to is a base case is walk. So walked and walking. Like this is swimming and swim. So base case is swim. Since male and female, this is a word tense. And country capital. So Vietnam is related to Hanoi. This is a similarity. And Japan is related to Tokyo, and China is related to Beijing. So here, what we are doing, we are capturing the similarity between these words, and these similarities are captured by with the help of techniques like cosine similarity. We have a famous technique, cosine similarity, and another technique is Euclidean distance. So these are the some techniques with the help of this we are we are finding the similarities between these words like swim, walked and walking. So these are the this is the first example, and second here you are seeing the second example. So we have a three dimension, and the three dimensions are the features like sky, wings, and engine. So these are the at x-axis we have engine, at y-axis we have sky, and the x and the z-axis we have wings. So let's say we have a words like rocket, drone, helicopter. So we all know that rocket has also engines, wings, and in the sky it can go to the space and drone. So these are all machines. So these are all machines. See, and here is the eagle, goose, bee. So these are the animals or birds, you know. So these are represented with different vectors. Like these are the vectors in the space. Goose is represented as goose in three dimension is represented as 2, 0, 1, and eagle is represented as eagle is represented as 3, 0, 3, and b is represented as 3, 0, 2. So this is the vector in three dimension. So this is the vector in three dimension. And what are the dimensions we have? At x-axis, we have engine, and uh, y-axis, we have sky, and z-axis, we have wings. So these are the three 3D vectors, x, y, and z. And these words are like helicopter is uh, is represented as a vector 0, 2, 4. Drone is represented as a vector 0, 3, 3, and the rocket is represented as a vector 0, 4, 2. See, since there is a similarity, we will find similarity between these vectors. So like, and how we find similarity? Cosine similarity. Like we have the formula cosine theta, cos theta is equal to cos theta of a vector dot b vector upon a magnitude of a vector dot b vector. So this is the formula we are using to find the similarity, and we find this theta. If the theta is small, if the theta is small, if the theta is small, we will say that there is a very much similarity between helicopter and drone and rocket, and helicopter and rocket. So and if the theta is big, see where this is the theta, like we considered here drone and eagle. See, there is a large theta. So we can say that there is no similarity between drone and eagle, since both are drone and machine, and drone is a machine and eagle is a bird. Okay? So this is the similarity we find for these vectors, and classify according to this. So I hope you will understand the word what are word embeddings. So basically, word embeddings are the numerical representation of a text. So and the vectors, and we already know since 12th and 11th class what are vectors. So vectors are nothing but uh, they represent in a dimension with which have magnitude and as well as directions. So I hope I it is clear what are word embeddings. So let's again. So how computer understand words? So there is a technique, the different techniques we have, like one hot encoding, one hot encoding. So in one hot encoding, what is done is like consider he is a boy. He is a boy. Sorry. Consider he is a boy, and again I am writing like this. He is a boy. So we find we what we are doing, we one hot encoding. What we do is we calculate the length of this sentence. So this is the what is the length of this sentence? So this the length of this sentence 1, 2, 3, 4. So here we make a we make an array of length 4, an array of length 4. This array contains the inputs as one hot encoding. In one hot encoding we do is we we like consider we have a text he. So for character he, we have a four input array, and he is represented as one represented as 1, and other is like 0, 0, and other words are represented as 0. So in this case, he is represented as 1 and other word is represented as 0. Like is we like is a similarity matrix. Is and is matching. We have placed it one and other are zero. Since so this is one hot encoding and A is A and he is not matching zero. A and is not matching zero. A is A and boy 0 0 0 1. This is one hot encoding. So in one hot encoding में हम क्या करते हैं कि जैसे आपको ही वर्ड दिया है ही का आपने एरे के अंदर आपको ही है तो ही को वन कर दिया और बाकी सब जीरो सो अब ये क्या बना रहे हैं एक स्पार्स टू डायमेंशन मैट्रिक्स बना रहे हैं तो ये स्पार्स मैट्रिक्स है स्पार्स मैट्रिक्स क्या होती है स्पार्स मैट्रिक्स इज अ मैट्रिक्स with which have more number of zeros other than one so sparse matrix in this sparse matrix we have a more number of zero like 0 1 0 0 0 0 1 0 and 0 0 0 1. So this technique is a one-hot encoding by which computers understand the text. So there is a difference in there is a disadvantage of one-hot encoding. First, it requires more is first it requires more storage requires more storage as the matrix is sparse. And since matrix is sparse, more number of zeros, which is not sufficient, which is not important to the our context. So and consider we have a word of 255 sentence, 255 words. We have a sentence of 255 words, and for each word we are doing one hot encoding. है ना? So for each word we are doing one hot encoding. Consider a sentence. Hello, welcome to hello, welcome to word embeddings. So consider this as a sentence. For this sentence, we are making words like hello. For hello, we have a one hot encoder vector like this 1 0. So what is the length of this sentence? 1 2 3 4 5. Consider this is not a comma. 1 2 3 4 5. 1 2 3 4 5. So the length of this vector is 5. है ना? So 1 0 0 0. So this is 5, 1 2 3 4 5. Welcome. Welcome again is a vector. So we have a vector 1, 0, 1, 0, 0, 0. Since and 2, for 2, we have 0, 0, 1, 0, 0. And for word, we have 0, 0, 0, 1, 0. And for embeddings, we have a vector 0, 0, 0, 0, 1. Okay. Since now in previous example, we have an array of 4 length. In this example, we have an array of 5 length. Suppose our sentence contain a length of 255 or let's say 300. So we are making one hot encoder vectors of 300 length each. So this require a lot of storage. Obviously, this is taking a lot of storage. So here is a one disadvantage. Another disadvantage is it is not capturing the semantic and syntactic relationship. Semantic and semantic and syntactic relationship. Syntactic relationship. So what this means is semantic and syntactic relationship. So the clear thing is like we have seen an example. He is a boy. So for each character, for each words, we are making a one hot encoder. है ना? So let's suppose he a boy. After we predict a word, he a boy. So something is missing in this. He is a boy. So one-hot encoding may not preserve the semantic or syntactic meaning. Suppose it give result like he boy. So this not make a sense. This is not making a sense. So this is one-hot encoding does not preserve semantic and syntactic relationship. So for this we have different techniques like count vectorizer and the TF-IDF term frequency. So these are inverts like this. So these are the other techniques we will discuss in later. So jump to the next slide. So we have seen what are word embeddings. We have covered all these. I hope it is clear to you. This is the definition: numerical representation of real-world object that machine learning and AI systems use to understand complex domains. Since, okay. So these are the what are embeddings. Embeddings are clear to you. So embeddings allow deep learning models to understand real-world data by keeping the semantic and syntactic relationship. I tell you what is the semantic and syntactic relationship. So this is the word embeddings definition. So here you are seeing in this example sentence embeddings. How old are you? What is your age? Many phone is good. Since this is the word embeddings represented by the vectors 0.3, 0.2, and 0.2, 0.1, 0.9, 0.6. So we have seen that we have given the words, and here we are giving the dots as well. So this dots as well means it is preserving the context of the word. So what means context is what is the meaning of this word? So let's suppose how old are you? Or we have a other example. Let's suppose Apple Apple is a good company or apple is a fruit. So these are the different these sentence have different context. We are talking about some organization here. Since we are organizing, we are talking about here organization, and we are here we are talking about a fruit. Since apple is a fruit, so these were related to apple, but with different context. So in word embeddings like this, these dots or 0.3, 0.2 represent gives the context of the word. So, and in other example, what is your age? A, age and you can see that how old are you? What is your age? How old are you? How old are you? And what is your age? What is your age? So these are two words with the same context. Both are asking for age. Both are asking for ages. And here you can see these are the vectors are also same like 0.3, 0.2, and 0.1. Like suppose this is my vector 0.2, 0.1, or zero point 0.4. So this is a vector with the same context. This vector has the same context. And the third sentence is my phone is good. My phone is good. My phone is good. Here you can see that the vector is zero. The vector represented is 0.9, 0.6, 0. Let's say 0.8. So this vector this vector this the number in this vector is 0.9, which is great, which is very far away from 0.2, 0.6, which is also far from 0.1, 0.8, which is also far from 0.1 or 0.4. So these vectors are very close to each other, so they represent the same context. Since same context, and this vector represent the different context. This vector represents a different context. So I hope it is clear to you what are word embeddings and how these word embeddings are represented as numbers to preserve the context. So I hope it is clear to you all. So, and another example here you are saying word embeddings good. This is the word embeddings. This is the word embeddings represented into a vector. Sentence embeddings. We have three types of embeddings: word embeddings, sentence embeddings, and document embeddings. Sentence embeddings. I am feeling good. This is also a embedding. Apple has performed poorly in last quarter's earning. So this will be a document. So this is the document embeddings. So I hope it is all clear to you. So let's jump into the next slide. So here is another example: king, man, woman, apple, banana, orange, football, gold, tennis. So this is another example like king, man, woman. It is considered talking about some person, है ना? And of some person or people. Like king is a man, king related to male, man, woman, and apple, banana, orange, fruit, and football, gold, tennis. Some football, gold, tennis, some sports. Since we have three different classes, person, fruit, or sports, है ना? So these are represented by vectors. So here is a one vector is missing. So let's suppose here is a one vector. Okay. So this is the represented by vectors like 4, 5. No. So this is the same vector. Okay. So this is these are the same vectors. I have made some silly mistake. So these are the vectors. So king is represented by a vector 4 and 5. So and these vectors are in two-dimensional space. So we have some characteristic to these characters. So two dimension 4, 5, 3, 3.5, 2, 2.53, and apple is represented as 2.5 minus 2, 2.5 minus 3, 4, 2.5, and orange or minus 2.5, and orange is represented as football. Orange is represented as 4 minus 2.5. Football is represented as minus 3, 5, minus 3, 5. Gold is represented as minus 1, 1.5 and 3, and ten is represented as minus 2 and 3. So, and here you can see, if you will plot a graph of this, so here we have x-axis, y-axis, and this is x-axis. So on y-axis, on x-axis, this is the class of person. Like we give the class as person, and this is the class of fruit, and this is the class of uh, sports. Since and we can see that we can see also here close similarity between these points. We can see here is a close similarity between these points. And if we talk about this is a distance. This distance is very large. So we cannot say that there is a similarity between these points. So we cannot say there is a similarity between these points. So here it is not considered as a similar points. So and we have also seen that these vectors are from different characters apple, banana, and orange are in the same similarity, and football, gold, tennis are in the same similarity. So this is the another example of word embeddings. I hope now it is crystal clear to you what are word embeddings. So let's go to the next slide. So why to use word embeddings? Word embeddings, what is the need of using word embeddings, and why do we use word embeddings? So word embeddings are used to enable vector search. So what is vector search or what are vectors? I have told you what are vectors, or you already know from your 12th or 11th class what are vectors, which have both magnitude and directions. Na? So this is a vector. And but in the embeddings we also have vectors. So this is the vector. This represent x-axis. This represent y-axis. So this is also a vector. So but embeddings can be anything. It can be image vector, document vector, audio vector. So these are transformed into embeddings, and we have represented it as a vectors. So these are the dense vectors. So basically, we have seen that is sparse vector and what are dense vector, which have which has less number of zeros and more number of numerical features. So these are the vector representation, and here nearest neighbor. So nearest neighbor what means is, so this is the nearest neighbor. You can see consider a point is this is a B point. So here a a is nearest neighbor is B. So this is the nearest neighbor. So in the in the result we find the nearest neighbor and then give the result, and can then give the result. And suppose we are using NLP task, and we user give a query. So this query is again turned into embeddings. We have seen that the query or any sentence, any input given to the computer is not understood by computer. So this query is converted and transformed into embeddings. So this is the embeddings, and this is the vector representation of this query. This is the vector representation of this query, and again this vector representation goes to nearest neighbor, and here we have database of like this documents, audio, and images, and this is also transformed into embeddings and vector representation, and this give and both combining this we are getting as a result. So this is a vector search. So this is a vector search. I hope it is clear to you what is vector search. And word embeddings are basic step for NLP tasks such as sentiment analysis, text classification, language translation. Suppose you are doing an NLP task from converting a English sentence to a Hindi sentence. So this is a my name is Aditya. My name is Aditya. And हिंदी मीनिंग इज मेरा नाम आदित्य है. मेरा नाम आदित्य है. So this is the translation. So word embeddings is very important in this task. Converting my name is Aditya to मेरा नाम आदित्य है. ठीक. So name is related to is similar to नाम है ना. My is similar to मेरा, and hai is related to hai, and Aditya is similar to this sentence meaning. So this is so we have vector which preserves the context of these vectors. So this is what word embeddings is useful in this case. So we will see our language translation project also in the next in the upcoming videos. So basically this is the use of word embeddings. I hope it is clear to you. And the word embeddings gives a way to recognize and capture the semantic relationship between words. I have told you what is the semantic relationship between the words. So these are the some use cases of word embeddings. So I hope it is clear to you. Now let's jump to the next slide. So types of embeddings. Types of embeddings. We have different types of word embeddings like bag of vector, TF-IDF, and word to vec, globe, word. So we will discuss in next videos. So we will discuss these types of embeddings in next videos detail with a detailed explanation of these topics like bag of word, what is bag of words, what is TF-IDF, what is the intuition behind bag of words. So bag of words basically do is extract features from the text. Sorry, TF-IDF and TF-IDF information retrieval, which is used for information retrieval and keyword extraction, word to vec, semantic analysis task, globes, word analogy, named entity recognition. We will cover all these topics like what is named entity recognition, what is sematization, what is lemmatization, what is stemming. So we will cover all these topics in upcoming video. And the last is BERT, which is a transformer model, which is used for language translation, question answering system. So these are some types of embeddings which we will be discussed in next videos in detail. So these are the these are some important discussion about word embeddings. So I hope these are all clear to you. So what are word embeddings? I will tell you again. So word embeddings are the numerical or vector representation of sentence or words that is given to the given as an input and converted it into numerical vectors. So I hope these all are points clear to you. So thank you all. And if you find the video helpful, so make sure to share the video with your friends and subscribe the channel for more videos and like the video. So we will meet you in next video. So till then, keep learning and keep practicing. Bye bye.